Hello everyone, Assalamu alaikum. Welcome to my channel. In this video and the next couple of videos, I'm going to show you how can we convert a callback hell code snippet to modern async-await based code snippet. And yes, as you can guess, I will show you using JavaScript. So let's get started. Before proceeding to the callback hell syntax, let's first reiterate or re-discuss why we come to this concept of callback hell. Why? We all know JavaScript is a single threaded application, right? So what does it mean? So let's first show you some diagrams. So suppose this one is a processor, right? And here, when we push some code here, this will be executed. And after that, our execution codes will be flashed out from the processor. So what I'm saying here, this one is processor, okay? Now, when we send a instruction set, that instruction set is called thread. So in a single thread, single push, we can set multiple lines of instruction, right? So suppose we are pushing this instruction set to the processor. So what will happen? This one will be pushed to here. Our processor will execute that line, and what will happen? This one will be flushed out from the processor. So this one we can say the call stack, where we actually execute our instructions. Now what happens if we have, suppose, hundreds of lines of instructions, right? So this one is this one, this one, this one. I'm just going to write some boxes here. And yes, as we can guess, so because JavaScript is an interpreted language, so it will just start executing from top to bottom and interpret it and start executing. So for the first time, it takes it, push it here, execute it, move it here, done. And it will go for the next instruction or instruction set. The problem arises when this instruction actually not manipulating our own instruction. We're actually trying to call some other process. So here comes the concept of process. What is a process? The process is our application, you can say. So for example, if our JS is an application, so we can say it like application 1, right? Application 1, and maybe we have another application in our system. In system means in our PC, that is called application 2, or to be precise, maybe it's a database. Who knows, right? So this database is also a different application, and this database is also executes its instruction into the processor. So that is different case. That is not our headache. The database can be MySQL, SQL Server, whatever. The problem arises when, let me use the brush, when my instruction set actually tries to get something from the database. So we are calling this database, and because database is a different process, it has different port number, different memory block, and different executing block, and totally different thing. It's not related with our own process or memory block. So what happens, because we are waiting for it, this whole instruction get blocked, right? Because we are waiting for the data to come from different service, different application, or even sometimes when we call network call API, what happens is we are calling some external network calls using our OS layer. So we call our operating system. Operating system actually calls the HTTP to remote PC, remote service, remote API. So in both cases, when we call this, we are waiting for the result to come. And because JavaScript is single-threaded, that means it can only execute one instruction at a time into the processor. So while we are waiting for the return, this code block is actually get halted for the execution into this box. So our next instructions, you can see, will not be executed, and the whole left execution blocks will be stopped, and the whole application will be unresponsive or blocked. So what is the solution? The solution is that we can actually call this external resource and move this instruction into some other place and clear up our processor thread or call stack or call block, whatever you can say, just Google it. And we can actually remove this from our processor mapping. And because we are moving out this instruction, you can see my mouse, from the memory or the processor. So we are actually doing a mapping. So we are actually putting some, how can I say, this one, suppose a pointer. Okay, we are putting a pointer here and telling that this call that, hey, when you come back, tell me the name, I will execute it. I means the processor will execute it. Okay, so suppose this execution, see my mouse, will take maybe 1 second or so, and when it is gone, the CPU or our call stack will be calling the next instruction set from the application 1, and this one will be executed, and this one will be flushed out. The question remains that when this call comes back from the database, what will happen? So when it comes back, we check, we means the processor or call implementation detail checks that this is mapped with the red pointer. So in this time, we move this into our call stack and execute it, and then we move it out of the processor call stack. So the interesting part is when we discuss about the event loop is whenever our call stack is empty, see my mouse, it actually checks, do we have any this type of pointer waiting for it? So we can tell this block as a callback. Actually, I forgot the name. So yeah. So whenever we are free, the main thread is free, it checks here if there is any callback waiting to be executed. If there is, it just moves this one from here and executes this and clears up the call stack. So pretty much that's all the basic theory. The problem actually solved by the callback mechanism. So in this mechanism, our JavaScript can handle huge amount of execution or instruction using a single thread or single core processor. Okay, so if we understand it correctly, now let's create a small program. So in this program, we will create a function which will actually mimic the creation of a burger. Okay, so let's pull this up here. Okay, so to create a burger, what do we do? First, we get the beef, then we cook the beef, then we get the buns, then what? We put the beef between the buns, then we serve the burger, right? So these are the instructions. Now let's just cut it and paste it here. So as we can guess, each of the instruction is asynchronous. Asynchronous means it takes time to execute. Now if we move this line in here, if we move this line over here, while we are waiting for the beef, the processor get blocked. So what we can do, we actually move this to here and call the helper. Helper means maybe someone else. Hey, get me the beef, and I can wait. I means the processor can wait. When it gets me the beef, then I complete this task to done, right? So when I complete this task to done, I am actually getting an amount of beef. So we can use this beef for the next instruction, which is cook the beef, right? So we are using the output of the previous instruction and set it into the next instruction. So you can see that each of the next instructions are waiting for the result of the previous instruction, right? So we are asking that, hey, when you finish this task, give me the result, and I will use this result to do the next task. So we are putting the next task as a dependency of or the dependent of the parent task. So it's kind of dependency thing, right? So how can we do this in our code? So in our code, what we can do, I'm just writing here the algorithm. So if you create a function, so get the beef, and this one will return us beef, right? So if we call get the beef, so we can get the result. So beef, and we can call cook the beef using p. But this syntax is actually synchronous. That means we are actually halting what? The CPU execution. But we cannot do this in a JavaScript world. So we will try to do a mechanism where we call a function, wait for it, get the result, and call the next function. So this mechanism is called callback, what I actually showed you before. Now enough talk, let's go to our implementation. So yeah, I'm just saving this. Okay, so let's start with a function named make burger, right? And when we finish the burger, we will return the result to the serve function. And we also have a serve function, and this one actually will not do any callback. This one will have the burger itself, and we will log it. Burger is served, so serving, sorry. like this. Okay, so how can I do that? So we can do make burger, and we can pass the serve burger as a callback. So when you finish the burger, call the serving function. That's all. So in here, this serve burger will be passed. Now what happens? So in here, yeah, Copilot is working perfectly fine. Let's just disable it for now. Can I disable it? Oh, yes, I think I disabled it. Okay, so let's just write the algorithms first. How can I do that? So get beef. Then when we finish the beef, get the beef, we cook what? Beef. Then we get buns. Remember, there is two actors here. Number one is the main chef who will work, and other one is the helper to whom he is asking for the resources. So it's like, hey, get me the beef. So he's waiting. The helper goes to the refrigerator, gets the beef, and come back and handed over the beef to the caller. That means the main chef. Okay, so think it this way. And while the worker is working around or going to the refrigerator, the main chef waits. Okay, it's like main thread and the helper threads. Then we put beef between buns. Then we serve the burger. So yeah, now if we write the functions, so the get beef, how should I write the get beef? It's like const get beef is equals, it's a function, so like this one, and we will have a callback function, right? So we have next step here. So let's just write const fridge equals top part of the fridge. Now, because it takes time, so set timeout. I'm just using, yeah, this one. We can wait 2 seconds. So it's just mimicking the timing here. So waiting for something to happen or finish. Now, const beef equals 1 kg of beef, and we are returning this to the callback function, right? Okay. And we can write something like log opening top part of the fridge, log getting the beef, and here log returning the beef, the 1 kg pack of beef. Nice. So we are sending 1 kg of beef. So the worker coming back to the main thread and handed over the beef. So in here we can call this one get beef. So what will happen when I get the beef? So I will write it here. What will happen? So it's the callback function. Okay, get me right. I am calling the get beef, waiting for it. But what will happen once I get the beef? So I'll just write it here as the callback. But this one is actually not done yet. So I will call the cook beef. So I'm instructing my helper, hey, cook the beef. So we'll have here cook beef, okay? And second thing here, I just disabled the compiler because it will just generate all of the code. It will miss the fun. So log cooking the beef using oil, and it will take time. So set timeout. Suppose it takes 3 seconds. It before was 2 seconds. Yeah. Now once I finish this, so we log it like cooked, and what should I cook? So we have to have the beef here, right? So it's like this one, beef cooked, whatever the parameter I'm getting as a beef, and then we will return. So next step, what? We are returning the beef, okay? But this one is the raw bit, so I can write 1 kg of cooked beef, okay? Now this one, so this cooked beef will be called when we get the get beef. So we are returning, yeah, so we are calling the cooked beef, but inside of that we're returning the beef, which is returning from the get beef function, right? Sorry, 1 second. This one like this one. Okay, so this next step will have a parameter beef. So this one will have parameter beef. So I'm sending this function to here, and this function will be called using this beef. So this beef is here. Now what? Now we will call the cook beef using the beef, and we'll call a second callback function. So it's like this one. Okay. See, I'm getting a flavor of callback hell because callback using another callback. Same thing goes to here as well. So I'm just copy pasting my other codes. No, don't want to get too much time here. So after the beef cooked, we will get buns, right? And we will call what? So when we finish the cooking, we'll get the buns. So get buns, and again when we get the buns, so like this, we will have the buns here. Okay, so we get the buns. Now we process the burger. So we will do another time consuming task, which is put beef between the buns. So as a parameter, we'll send the buns, right? And we'll send the beef. But this one, after the cooking beef, this one will be like cooked beef. Okay. And as a callback function, the next step, what we can do, we can get the result from here. We are sending what? Another function as a parameter. So this one is B. Why should I just write burger here? Okay. So we'll call the callback and we will return the burger to the caller. So we are passing this one here. We are getting cooked beef here. Yes. COCKET. Cooked beef here. Yeah. Now it looks good. Okay. So yeah, the classical callback hell. Now let's run it. So each of the time will take suppose 2 seconds. 2. Now if I just run this, what will happen? Okay. So let's open this. CD root to async ls. We have one callback hell, so node 1. Yeah, it is being executed. Nice. So thus we actually completed our first step. How can we create a classical callback hell example? In the next video, I will try to convert this callback hell to promise-based calling. So hope to see you in the next video. Goodbye. Assalamu alaikum.